and we are looking at the second derivative. So our implicit differentiation that we did yesterday, that doesn't come up in today's lesson. I'm sort of going to set us up for later on when we do related rates. But for right now, we're going to look at higher order derivatives. So we've done the first derivative. And what we're going to look at now is what happens if you would keep on going. So here are some second derivative notations. So instead of just one dash, we add a second dash. Or in Leibniz notation, it gets a little bit crazy because you add some squares, but on the top the squared is in between the d and the y, and the bottom it's after the x. So it's a little bit different notation. All this means is if you could do the derivative once and get an answer, do the derivative of that again, and that would be your second derivative. So it's just doing the same thing again. So in a lot of ways, this isn't very hard at all if you're strong with your first derivative. So here's an example. So yeah, here's just saying that we just keep on going with our derivative. So here's our first example. If you have f of x equals x cubed minus 5 over x. So I could, first of all, I'm going to write this in a form where the derivative of each term is going to be easy to do. Then my first derivative is going to be 3x squared, bring the 1 out, negative 1 out in front, subtract 1 from the exponents. And your second derivative is just taking your derivative of your first derivative. So now the 2 comes out in front, and the negative 2 comes out in front, subtract 1 from the exponents, and we have our second derivative. Any idea what the, well, third derivative isn't too hard, but what happens if I said something like the 50th derivative? Do you think you could figure it out? Or the 100th derivative? You just have to keep going and see if you could develop a pattern. But that's all the second derivative is if you can find the first derivative and keep doing your derivative rules as you go on, you can find your higher order derivatives. So here's just Leibniz notation. If y is equal to x squared minus 3x cubed, what kind of rules would I have to do to find dy dx? It's going to be a chain rule. Can you see that there's a function inside of another function? So when we do the chain rule, I talked about hugging your function to find out what your outside function was. Going from the outside, can you see that your first function is the cubed? So if we do the derivative of something cubed, the 3 would come out in front. You keep the inside the same, subtract 1 from the exponent, and then we're going to multiply by the derivative of the function that was inside. The inside function was x squared minus 3x. Its derivative would be 2x minus 3. That's our first derivative. I'm already sensing I'm going to need space for this one. Second derivative. What kind of rules are there going to be? There's going to be a chain rule and a product rule. And you see that there's a product here. So we can consider one thing our first function and the other one our second function. So how do we do the product rule? We keep one the same. So let's keep the first one the same. Multiply by the derivative of the second one. The derivative of the second one is just 2. Plus, keep the second one the same. Multiply by the derivative of the first one. And our first one is a chain rule again. So our outside function is the squared. So I bring the 2 out in front. Keep the inside the same. Subtract 1 from the exponent will just be a 1. Multiply by the derivative of the inside. And that would be our second derivative. mental math. That's any ideas if you kept doing this and you got all the way to your 8th derivative? Any ideas? Well, here, like if you do this, you're going to have chain rule here and a triple product rule there. Is that going to be fun? No, it's not going to be fun. Okay. Well, the answer is going to be 0. Why? Well, let's say you decided not to do it this method, but you decided to expand this completely to begin with, which would be x squared minus 3x times x squared minus 3x times x squared minus 3x. Does it make sense when you expand this completely that your first term is going to be an x to the 6th and then you're going to have stuff after that? Yes? Now, if I have an x to the 6th and I do the derivative once, I'm going to get an x to the 5. If I do a derivative again, I'm going to get an x to the 4, then an x cubed, then an x squared, then an x, then just a number. And what happens after you get just a number and you do the derivative? You're going to get 0. So does it make sense that if I did it 8 times, 8 times probably is more than enough, because you'll have, starting with an exponent of 6, you'll get all the way down to 0 in the end. So there is a list of some practice for the second derivative.